Hi everybody, good morning. Welcome to this webinar. Thanks for joining. So today we would like to share some of our experiences and learnings to develop a solution for version managing. Based on our various discussions and business requirements from customers, we identified there is a need uh, for managing versionings for different artifacts, whether it could be documents, whether it could be binary objects. Uh, However, those solutions should be hosted in Azure. We noticed that there is no such solution available today on Azure, so there is a custom solution to be developed to meet such business need. While developing this solution, we came across multiple avenues and identified the optimum solution, and we would like to share our experiences with you in this webinar. So in today's webinar, we will touch base on what is a version management system, and we will give a brief on what version management system that we planned and tried building as part of meeting the business needs, and what is the solution that we proposed, and a associated demo uh, based on the solution that we have proposed, and what would be the benefits that a user will benefit from such solution. And before the end, we would like to take any questions from you. Anytime the questions can be entered in the webinar window, and we will take them up and we will answer them before concluding the webinar session. So I will start with a brief introduction of today's presenters. I am Shini Pule. I lead Azure and mobile practices here in Spadeworks. I have around 15 plus years of experience in IT industry, handling various roles spanning from developer to lead to managing teams to practice lead. So we delivered various complex solutions to different vertical segments and customers spread across various geographies, US, Europe and India. I have my colleague Saif. Saif is a solution architect. I would request Saif to introduce and further take on the webinar description. Saif.
Thank you, Srini.
Thank you, Srini.
Hello, everyone.
Hello, everyone.
My name is Saif.
My name is Saif Manle,
and
and I'm a solution architect
in
Spadeworks. Sorry for a bit of technical glitch. I'm a solution architect in Spadeworks. I have a total of around 13 to 14 years of IT experience all throughout in Microsoft technologies, spanning from VB, ASP, .NET to SharePoint to cloud right now. I mostly concentrate on designing and architecting solutions for our clients using the different Azure-based services and features that are available. Now, as Shini mentioned, we have a requirement of version management system, and a brief of that requirement I've put down in the next slide. Basically, the requirement was that the system should be able to manage or maintain versions of different kind of data. Now, this data can be a file, so the binary of that file, or this data can also be a .NET object. Say example, a user profile object or an order data So the moment a user changes his profile information, the previous profile information should be saved as a version in the version management system, so that in future at any given point of time the historical data uh, of a .NET object or of a file can be easily pulled out and used for any future reference. Uh, Also, uh, the system to be developed should be such that uh, any future components such as structured data and .NET objects or files of different formats that needs to be added uh, can be easily added to the version management system. That means the version control capability, the system should such be designed and developed that adding a version control capability to any more objects in future should be very easy. It shouldn't be tedious, it shouldn't be time consuming. It should be quick and easy. And mostly the data, very briefly about the versions that need to be saved is the date at time when the version was created, the user who created the version, and version details in the sense some user comments and stuff. So this seems to be pretty similar to any version control system such as Visual Source Safe or TFS or whatever. But all those are file management systems. Here we needed some service. Here we needed it as a service so that it can be used in an application. A lot of research and analysis in search for an existing solution went in vain. There weren't any, or rather I should say there aren't any ready solutions available uh, in open source community or even in paid versions which provide you a kind of a version management system or service that can be easily hooked into your existing applications. So then the only option was to develop it ground up. Now developing ground up, we actually considered different options, weighed its pros and cons, mapped it across with the requirements that we had, and then finally came down to a final technological decision as to which one we would end up using. The first and very straightforward approach would be, since the requirement is to save a structured data, something like a user profile or an order data, it would have an equivalent table in the RDBMS. So in the slide here, the example that I have given is, suppose the user profile is saved in a user table. And now this one record, whenever it changes, the previous changes has to be maintained. So what could have been done is, we could have an equivalent user version table, which carries the same structure of the user table, since all the data of the user table has to be stored. Plus it would carry the columns of version specific information, which is what is the version date time, who created the version, and what is the version ID, version 1, version 2, version 3. It would work, right? But then there's a lot of development effort in terms of implementing it. You create the table, you create the stored procedures and stuff, and you do the same stuff again and again for any new structured data that you need to add to the version management system. So essentially it won't be like a service. You have to add tables to the database and write code and stuff. It won't end up being a plug and play service kind of a thing, right? And in future also, any more data types need to be added. The implementation is a time consuming and effort consuming process. Then what we finally decided is, we tried to identify what is the different kind of data that we will be versioning. The commonality that came out to be, the data is going to be either the structured data in terms of .NET objects or your files. Now, files can easily be streamed and stored in a separate physical location. Likewise, a .NET object can also be very easily streamed into an XML or a binary object and saved onto a separate storage location. So with this approach, what got finalized or formalized is that yes, regardless of the different data, we would not be storing that data in SQL tables or something. We will serialize the data and store it in a central storage location. Now, the question here is, where would you be storing it? As the slide says, that we will be storing it in a Azure blob storage. To a lot of people, if they are aware of Azure, they would say that the choice is pretty straightforward because if you are storing some data, you would go for blob. But actually, it's not so. We had some other options also. We did consider using storage tables, since storage tables also allows the same form of entity format where you can store a .NET object into storage tables. So that was considered. But the reason why we discarded it is storage table has the limitation of maximum 1 MB size per entity, and what our requirements was that our a .NET object or a file can actually be greater than 1 MB. So then whole splitting of the data into multiple rows and multiple columns also, since each property of a storage table cannot be more than 64 KB, even that is the limitation. Using, we also considered using local fat entities. But everything was coming out to be that the solution was coming out to be pretty complex. The other alternative or a simplistic solution was to use blob storage, and more so because blob storage does give us the functionality of versioning the files or the blobs that are stored in a blob container. In terms of Azure blobs, these versions are called as snapshots. So at any given point of time, a blob which is already added to an Azure container, a snapshot of that current version can be created with that same blob, and that's how you can maintain the history. So seems to be fitting pretty well to our requirements. We decided to go ahead with this approach. Also, as you know, Azure also supports associating custom properties or metadata with the blobs that are added to the blob containers. We plan to utilize this feature of blobs, Azure Storage, to store the version related data, such as the user who has uploaded the version or the file, the maybe the user comments into the metadata of the blob. So this slide actually shows as to how you would create a snapshot. So the whole idea here is when a new blob is added, at that time the blob is just added to the container. No snapshot is created. A snapshot is only created when an existing blob is going to be updated, right? So before updating the blob with new data, the current blob, a snapshot is created so that the history is maintained, and then the blob is rewritten with the new version of the stream or new bytes that are uploaded. So the code here in this API demonstrates that first you create a reference of the blob, right? And before using the upload from stream method to upload the new stream of data into the blob, you create a snapshot of the blob, right? So a version is created, and when you are uploading the new blob data, at that time also associate that blob data with the custom properties of user as to which is the user that has updated this data. Moving on to next slide. Now this slide shows the code that you would have to require to retrieve the different list of snapshots from an existing blob. All you need to do is you need to have a snapshot time. So every time you create a snapshot, the snapshot is associated with the time. So if I create a snapshot at 11 o'clock, to retrieve that snapshot that I had created at 11 o'clock, I need to provide that exact time to the cloud blob constructor. The URI would essentially contain the container name concatenated with the blob name, and the blob client would contain the service client reference. So the important factor here is the exact snapshot time, which would return you back the snapshot or the version of the blob that was added to the container. Moving on, I'd like to show a demo as to how we have done this. Here I have applied a bit of version management system to the same file management system that we covered last week. Now if you see this file management system, we have configured using ACS with two separate identity providers. One is Google and another is Yahoo. Now here first I log in as a Google user, okay, as a Google user, and then I'll upload a file to the system. Then what I'll demonstrate is I'll log in as a different Yahoo user and I'll check in a different version of the file and show you how the different versions are available. So if in my blob container, right, now I'm going to upload a new blob. I'm going to choose a file, over here, say I have selected penguins, okay, and I have uploaded the file. Now if I go here, I have the file available, and if you see there is no version or snapshot history here because there is only one version, which is the latest version, which I can easily download using download and save it to my computer or whatever, right? And then if I open it, yeah, so this got uploaded and downloaded. Now let's say a different Yahoo user logs into the system and sorry, I'll go to the same file over there and with the same penguin blob, I'll replace it with some other blob. Team share folder, I have this penguins, which is now I'll check in with a different bits of file. Maybe in Penguin I will try to upload a koala picture. Alright, now when I check in, the file is getting uploaded. Now notice here, this download is the latest version. The blob remains the same. The blob properties in terms of name remains the same. Now there are two versions. One is the latest version, other is the historical version. So this is the latest version. This should actually give me the koala that I have uploaded. When I download this latest version, it should give me koala. Let's see what it gives me. Yes, koala. Now the trick is, am I able to receive the original version, which was the penguin version that saifulghani@gmail.com has updated or uploaded? The information is seen at least. So saifulghani@yahoo.com has updated or uploaded the latest version. At that time, the snapshot of the previous version, which was uploaded by saifulghani@gmail.com, has been maintained. If I download this and if I open it, yeah, see, so that's how, though it is a single blob in the blob container, using the snapshot functionality, we are maintaining the different versions of the file, plus we are using the custom properties to save the version data. Now a quick look at the code. Alright, so if you see here in the save stream, what we are doing is, if history has to be preserved, right, when you are uploading the stream into the blob, that means if you want to maintain versions, then a snapshot of the current version, before overwriting that version, a snapshot is created. After the snapshot is created, the new stream that is available is uploaded using the upload from stream method. Right? And the user who has uploaded this new file, its data is being added using the set metadata method. Okay. Now let's see how do you retrieve the data of snapshots. Basically, to retrieve your snapshot data, what you need to do is here. Notice, remember I mentioned that every snapshot has a snapshot time. So in your link query, you need to specify that the snapshot time has a value. So actually this is a nullable property, and your snapshot time will always be null if a blob doesn't have snapshot associated with it. Right. So essentially what here I'm doing is I'm looping through all the blobs in a container. I'm checking out whether it has a snapshot time, has a value. That means this is a snapshot value, and I'm retrieving that blob over here. Same as what we have demonstrated. Now the usage scenario for this is, again, as we mentioned at the start, if you want to develop a kind of a version control or version management system where you want to maintain different versions of the file, right? Say for example, uh, you have a document authoring system where a single document is going to be authored by different users, uh, right? So online you put up the file and then different users can log in, check into it, check out to it, make changes to it, and you would like to save the versions uh, every user has checked in. So at that time you can use this. There is other feature of you know Azure blocks that is available is setting a lock or a lease on Azure block, and you can use this feature as well in your version management system uh, to make sure that if a user checks out a file that or a blob, that blob is locked so that no other user can accidentally change it unless until the user who has checked out the file checks in with a newer version of the blob or discards his checkout. Uh, Having said that, I'm done from my side, Srini. Back to you.
Thanks, Saeed. Thanks for sharing the code and demo. Hi everybody. If you have any specific questions in this, please let us know. So we are happy to answer those questions. So fine, we hope you got some insights onto how we can leverage Azure Storage blob snapshots. So we have two things here. So one is Azure Storage blob, but we also gone into the next level of Azure blob, which is the blob storage snapshots that have been used for developing a version management system uh, that can be hosted on Azure in tandem with the file management system, which we have demonstrated in our previous webinar. You can go to YouTube where these webinars are being posted for your reference, and you can get back to us for any kind of clarifications or questions in this regard. So before concluding, I just want to touch base quickly about SpadeWorks. SpadeWorks is a software development organization located in Pune, India. SpadeWorks is founded in 2006. Main focus, business focus is into software development services as well as product and solution development to various customers. And another key focus area for SpadeWorks is mobile application development. Today, SpadeWorks is having a 85 plus development team primarily located in India, but SpadeWorks offices are spread across different global locations, including USA, Canada, and Netherlands. So the primary focus SpadeWorks from a technological perspective is on SharePoint and Windows Azure. Of course, as I mentioned earlier, mobile solutions on Android and Windows Phone along with iOS is another forte for SpadeWorks. So SpadeWorks in the last few years have delivered around 150 plus projects to customers distributed across the globe in India and outside, including US and UK customers. SpadeWorks also won prestigious awards from NASSCOM. NASSCOM is the industry body for software companies in India. So SpadeWorks has been awarded as one of the most promising IT companies in 2010. So that's all from my side, and we would like to provide any further details you want to look in this regard. Please touch base with us, and we would be glad to share our experiences in not only in the version management but any other Azure related areas. Thanks a lot, and thanks for your participation. And please check out the recordings will be available on YouTube.
Thank you, Shin.
Thanks a lot.